When I first set out to code maze generator, I faced a dilemma: canvas or HTML elements. I implemented this maze generator with DOM elements, not canvas, because seeing each cell as a div makes the algorithm behavior visible. Performance wasn't a priority. Canvas would have been faster, but hiding the mechanics behind fill-rect calls defeats the purpose. Here, the inefficiency is the lesson. You watch the grid mutate step by step. The code matches the mental model. No abstractions, just cells, walls, and randomized depth-first search laid bare. Depth-first search maze generation begins with a grid of unvisited cells. The algorithm starts at a chosen cell, randomly selects an unvisited neighbor, and removes the wall between them, marking the new cell as visited. This process continues recursively, extending the path until no unvisited neighbors remain, a dead end. When reaching a dead end, the algorithm backtracks to the most recent cell with unexplored neighbors and repeats the process. This combination of randomized path extension and systematic backtracking guarantees a perfect maze, one with exactly one solution path between any 2 points. The resulting maze exhibits characteristics long corridors because DFS prefers exploring as far as possible along each branch before backtracking. In this implementation, we visualize the process in JavaScript, coloring active paths green and backtracking steps red to demonstrate the algorithm's operation clearly. The Wikipedia article Maze Generation Algorithm contains excellent description of DFS algorithm. I used it as my primary info source while building this program. Now to the code itself. I implemented everything in a single HTML file. This approach eliminates build tools and dependencies. All logic remains visible at once, from the DFS algorithm to the DOM manipulations. The HTML provides the structural foundation, a header with interactive controls and a container div holding the maze grid. The CSS establishes visual rules, using viewport units for responsive sizing, flex grid for layout control. The JavaScript implements the core algorithm in 3 phases. First, it initializes the maze grid by creating a div for each cell, with calculated dimensions and borders. Second, it handles user inputs through event listeners for sliders and buttons. Third, it executes the randomized depth-first search by tracking visited cells, removing borders between connected cells, and implementing backtracking when dead ends are encountered, all while updating the DOM in real time to visualize the process through color changes and border modifications. The entire system operates through direct DOM manipulation. I am not explaining every line here for 2 key reasons. The code is heavily commented at every line, so you can dive deeper anytime. Let's be real, nobody wants a 2-hour lecture just to watch a maze get built. The goal is to show the algorithm's soul. Pause, tweak the code, and experiment. I'd rather give you concentrated insight than fake completion by dragging it out. The link to the file is in the description. I will scroll through the file now. That's all for now. Have a nice one.